Hey everybody, how are we doing? How is everyone doing this morning, this afternoon? It's earlier here in Texas. It's 1 hour earlier. It's raining outside too. So it's office hours. You can go over material. Yes, nice, awesome. Good to see you here, Campbell, Sarah, Bailey. We got Tori here, everyone, Kayla, Paige, Haley. Good to see everyone. So we know there's gonna be more review for the exam. We can definitely review for the exam. I'm doing great. Good morning, or it's afternoon now. What am I saying good morning for? What am I saying good morning? Let's see here. I was sending out announcements as we were doing that. Got all this jump output up. We always start by talking about the week right now. Let's see, we're going to start with 320 for the moment, and then we're going to head over to 201. So be asking your questions. I think I got everything up and good to go. Let's get some 201. Hey, Caitlin, good to see you here. So we got 201 getting ready. Let's go take a look at this right here, and let's see, 320 to start. So I think I have the 320. Let me make sure I have the 320 assignment up. So 320, we're going to start with yours this week. So 320. It's raining outside. It's raining College Station, Texas. It's crazy. I had to go pay the rent. So I'll be like, rent time. Let's do this. Here we go. Let's take a look here. We got BAS 320. Here's Brian's weekly advice. Now, we have some, I know, Kayla, you're 320. So if you are 320, I want your advice. I want your questions here. Because one of the biggest things, one of the most important things right now is starting the assignments early. And so I made this assignment this week a little bit shorter, and I added in a thing about the executive summary. Just a quick note on executive summary. Executive summaries are basically, as 201 knows, basically your whole report condensed down. So you still need to do your report, but why would someone need an executive summary? So 201, this is important to you. I feel like sometimes 201 might tune out, be like, nah, it's not important to me. But why would we need an executive summary? Like, why do we have an executive summary? What is the point of an executive summary? What is the point of an executive summary? What is the point of an executive summary? Like, why do we have an executive summary? I kind of go over it right here. So I kind of explain it. And so, elevator pitch, exactly, Addie, great way of putting it right there. It's an elevator pitch of your report. It's basically your report condensed down so someone doesn't have to read the whole report. So someone's like, give me the overall review of it. Exactly, Kayla, you put it perfectly. Have I said that in class, Kayla? Because hopefully that's what I want to communicate, is that people could read it instead to get to the data. Yeah, exactly. To get all the information quickly to someone so you don't have to read through all the key findings in the report. Exactly, like what's the point of the report, what's the key findings, and what's the action items. So sometimes there is action items, sometimes there's not, but it's everything. Awesome. Well, I'm glad I've said that because I want to make sure everyone understands clearly that the executive summary goes at the start of the report. It's basically in lieu of the report. Like, it sounds crazy. It's like, why would you have an executive summary if you have a report? Well, it's so someone can read it, as Kayla said, instead of reading your report. So I put this right here, an executive summary reminder. We get down into your project or assignment project, all this good stuff right here. So the good news about 320, if anyone in 201 ever thinks about taking 320, is that there's less assignments. There's, right now in 201, you have visualizations, you have My Pearson, you have homework, you have Canvas content quizzes. In 320, there's really just each of these kind of weekly assignments. If you notice, we've got some stuff here. You're going to make a regression, which is something we just did in 201. And there's going to be key assumptions. Is the linearity, QQ straight enough, no outliers. Interpret the slope in context of the problem. Now, here's a big thing. Make sure to use 320 interpretation. We'll be going over that probably first day of lecture. It might be towards the end of first day of lecture. Might be towards the start of second day of lecture. So watch out on this one. This is where I see people losing points, and I think it's worth 8 points on the rubric. Interpret the intercepting context of the problem. Pretty 201. Would you attempt this assignment right now, 201? What are you thinking, 201? You've got to interpret the slope. Now, their slope's a little more complex to interpret. We do a little more in-depth, more accurate interpretation in 320. We basically 201's very mathematical and 320 is more practical interpretation. So we focus on very practical interpretation in 320. So we're like, okay, here's exactly the practical interpretation. Is your model statistically significant? Ooh, 201. This is a big thing. So 201 should help out here. Is your model statistically significant? As of right now, yes, 201's ready to help out. Is your model statistically significant? 201, this is review for the test. How would you know if your model is statistically significant? Help out 320 right here. Kayla and others might know, but 201, how would you know if your linear model is statistically significant? How would you know if your linear model is statistically significant? How would you know We'll actually have some output right here. Not that that's output when I was like making sure the assignment worked and everything. I always go through and do the assignment myself. So while I'm writing the assignment, I basically do the assignment to make sure it's working. So, little hints in here. How would you know if your model is statistically significant? Justin, you are right. And specifically, what p-value? You are correct. And so, Ori, you are correct too. And specifically, what p-value? Specifically, which one? It's a specific p-value because less than 0.5 means statistically significant. But most importantly, we're basically giving away some answers right now because there's two p-values on the screen. Right now, we have a p-value for the what, and we have a p-value for the what. So this is a good review for 201. For 201, you should definitely know this. This is test review right now, so we're covering some 201 topics as we talk about this right here, which is a good idea. So 320 review, 201 review, because this assignment now of the slope, Justin, you're right. So this one, they're both statistically significant. So of the slope will be the significant one. We actually have R squared right here, which says only 3% or 2.7% of the variation in the y variable, which I was trying to analyze. Average wind speed is explained by average temperature. So only 2.7% of the variation, which is a very small. And now 320, you should know R squared is practical significance. So we talk a lot about practical significance. And look, what do you see right here? Interpret the R squared of the problem. This is a different problem. Mention its practical significance. 2.7% of the variation in y is explained by the variation in x. So interpret the RMSE, that is the root mean squared error, which is also the residual standard error, which is right there. We'll cover that in class. That's the next one. The next problem covers ANOVAs. We'll go more in depth on ANOVAs in class. But as you can see, hopefully I don't think this is too bad. There are a total of 4, 8, so 15 questions. And you'll write your report. A lot of it's output. So overall, Kayla and everyone else, what do you think about this so far? The notes have the interpretations too, so you can work ahead. But when you get stuck, ask questions. So the biggest thing for 320 this week, 1, start the assignment early. Start the assignment early. Ask questions on Discord if stuck. Email Brian if stuck. Please email me. I will get back to you. Sometimes it does take me a moment. Like yesterday, we did a review session, a Kahoot, and then I ate dinner and watched an episode of Fear Factor, best show ever. And I came back and I think I had like 40 emails and I was like, oh gosh. So it took me a moment to catch up last night because sometimes if I don't answer emails for about 3-4 hours, they can stack up. So I'm sorry if sometimes, especially during busy times, but that's why you want to start early, and usually I can get back to people pretty quickly. So in the chat, do I get back to you pretty quickly on email? So I'm sorry if if it took me 5-6 hours. I consider 5-6 hours a while to get back on emails. I'm pretty caught up. I think I'm caught up to like 10 a.m. this morning. I think I'm caught up to about 10 a.m. I could go look real quick. I am currently caught up to I'm caught up to 10:43 this morning, which is 11:43 your time. I'm caught up to 11:43. No. Yeah, 11:48. I'm gonna stop looking at emails. Usually within the hour. Addie, that's awesome. Well, I can't always promise that, but I'm gonna try my best. Please email me. Anyone 201 320. Please email me. Please email me. Attend class live. And why are we attending class live? Activity points. And I'm gonna add on here this week. I would say start reviewing for test. And also, I think that's good. I think we're good to go. And that's the 320 advice. That's the most part. Yeah, that's the toughest part, Kayla. Practical significance is like, how would you make a case to your boss about, what's up, Adam? Good to see you. How would you make a case to your boss? So a big thing for regression is going to be R squared. So R squared for correlation and regression is practical significance. So make sure to have that note because p-value is always statistical significance, and then R squared is practical. How long should it take to hear if you can adjust my 201 exam time if I have a scheduling conflict? We give the exam earlier, or if you are sick or get into a car accident, we have, good to see you here, Coop. And if there's a problem where it has to be not on that day or before, then we give it later as a comprehensive makeup. So Justin, please email me with the conflict. If it has to be taken later, we have a comprehensive makeup for people who have to miss the first exam. So our goal is to, have it on that day or earlier that day. Some people are taking it tonight, but email me as soon as possible. And I've also got the form that I sent out. So 201, remember, I did send out a form. Where is that form? I'll go grab that form over here. So there was a form I sent out. If you do have a conflict, and we'll head over, let's start talking about 201. It's not 201. Email Brian or use form immediately if you have time conflict. So please fill out the form immediately. Where did I put that form at? So many announcements, right? I know I sent it. Regression review. My brain is blinking. Oh, that's BAS 320. I was looking at the wrong class, and I was like, well, I know I sent it to every class. I checked these things. And so here we go. Exam 1 important info. Exam 1 important info. Here we go. Here's the exam 1 important info. You should definitely check out this announcement right here. I know I sent a lot of announcements, but check out this important announcement right here. Is there an issue, Coop? How could you go through an example of a good executive summary class? Yeah, we should do that. We should talk about a good executive summary. And so right here, you can see, here's the everything you can bring, calculator, UTID, writing utensil, formula sheet. Oh, and then I should have said scrap sheet of paper. Someone I think mentioned that you can bring a scrap sheet of paper. So sorry about that. I'll make sure to mention that in class. If you have a conflict, please click here. So here's the conflict sheet right here. If you have a conflict, make sure to send me notification of this conflict. Yep, lockdown browser with webcam. That is correct. And so it should say on here, respond us on Canvas via lockdown browser with webcam, all that good stuff right there. I need to make sure to tell everyone you can bring a scratch sheet of paper. I spent so long writing this announcement, and no, it's got one error. I think my brain turns to mush too, Coop. It's like you try to, I don't know, writing that announcement, my brain turned to mush when I was doing that. So use form immediately if you have a time conflict with the exam. Send verification. So also do not forget, we have Canvas content quiz due tonight. Kahoot will help. So the Kahoot, has anyone done the Canvas content quiz that is due tonight? 201, has anyone done the Canvas content quiz that is due tonight? Because I know there are some questions that we did during the Kahoot. And Danielle right there, and Tori and Justin, how'd you do on it? How'd you do on it? And good to see you, Jensen, everyone, and Ben. How'd you do on it? Did you get 100? You can tell if you got 100 yet. Kahoot helped so much. Please don't forget this. The Kahoots, we cover in the Kahoots a lot of the content that is on the Canvas content quiz, like maybe that residual question about what do the residuals all add up to? Does anyone know what the residuals all add up to? So super easy. I like hearing that. 100% Kahoot helped. So that's what we like to do is we like to have the Kahoots. Kahoots are meant to help, and they cover the Canvas content quizzes, and the Canvas content quizzes. Nice job right there, Daria, telling what the residuals add up to. The Kahoot from yesterday has good stuff. The Kahoot from yesterday goes over a bunch of the exam material too. And then we also did the exam review yesterday before the Kahoot. So we went through a lot of topics, and we'll probably go into more exam review here in a moment. The residuals add up to 0. You are exactly right, Addie. And so also, please, please, please start checking out the exam review page. So I'm just going to put the link to the exam review page in the chat. If you didn't know, we have this page right here. You go to exam review material. I need to remove those Kahoot links because they don't go to the right thing anymore. Putting up static links is just a bad idea. Oh, well, let's show that off while we'll do this. Just so in case someone's watching this right now who doesn't know, we do have, so let's put up, I'm in the wrong chat. 2 seconds here, everybody. 2 seconds. Hopefully this doesn't blip YouTube. Okay. Nothing crazy happened. YouTube didn't freak out. YouTube didn't go crazy and explode today. Okay, so let's copy the link. And let's go right here and put exam 1 review material. So if you're watching this right now and you're like, where is that? It is in the chat right now, 3 times pasted right there. So what have people been using to review? Once again, we've got chapter review videos, which are more kind of like classic review videos, going over the chapters that are on the test. And then we've got right here, the speed runs, which are like kind of fun, more Brian being Brian type reviews. And then we've got the test question reviews right here, which give you versions. And I think I put all those at the end of the list anyways. So go through this first part, Kahoots. Yeah, and Kahoots are Canvas content quizzes. Kahoots should probably be first, Elizabeth, I think. And I should put a Kahoot playlist. Maybe I'll go in today and put a Kahoot playlist on here. There's a lot of other resources. We've got the formula sheet, which is very, very small. That's the formula sheet. And we've got the topics and all this good stuff. So please start reviewing early. Start reviewing for test if you haven't. And last but not least, the last bit of advice. Well, one, attend class all week. Someone's like, no, Brian, I'm taking that test. I'm not attending class. Here's the thing. I noticed that people generally don't do well on the material we cover right after the class. And we're going to cover decision trees. And when I do decision trees later in the semester, when I do decision trees, like when we start to do it on test 2, people will be like, I don't remember this. I never saw this. And they might be right because they didn't go to class. And I understand. I mean, the world is crazy. The world's on fire. Like, believe me, I feel it. And I do understand if somebody has to take a day off. But if you can attend class, I highly recommend it. And yep, we've gone over chapter 8. Chapter 8 has in it extrapolation, lurking variables, more checks on conditions, and all that stuff. So check out last class's video where we go over chapter 8. And the last thing, because Clarissa, you bring up a good point, because I've got number 5 right here, chapter 8. And I need to send out a reminder tonight to people. And I've been meaning, because I was going to send it out last night, and then I just... Anyways, 320 can tell you that the assignment got finished up pretty late because I was working on that, and I've got anyway. Okay, I'll sleep at some point. But the chapter 8 homework and quiz, those are due tomorrow night, the same night as the exam, and I want to explain why. We like to have a consistent, your quizzes and homeworks are always due when, everybody, 201. When are your quizzes and homeworks always due? Either this day or this day. So your quizzes and homeworks are always either due on this day or this day. Your quizzes and homeworks are always due on like this day or this day. So if you're in 201, you know Tuesday, Thursday, exactly, Tori. So Tuesday or Thursday. And so here's the issue. Tori, we're going to make you mod because that's good evidence you are. We don't usually mod people, but I think Tori's been to a lot of the streams, so we're going to mod Tori. No preference on a calculator as long as it doesn't have internet capabilities. So you're probably good as long as you don't have like a super cool calculator that has internet capabilities. So with it being due on Tuesday and Thursday, I do understand the exam is tomorrow night, and there's an issue. One, if we put it due last Thursday, you'd basically like be doing the material because we did it last Thursday, and then taking the quiz on it that night. So it'd be like you'd have like a not even a 12-hour turnaround. You'd have like a 8-hour turnaround. Yep, Eddie, that's a great calculator. I like those a lot. Not required, but good calculator. So why not put it to the next Thursday? Why not put it to Thursday later this week? Well, the issue is if we put it to Thursday later this week, then generally speaking, and you might be like, yeah, that's me, a lot of people do the quiz the day it's due. And by a lot, I mean I see the numbers over 50%. So with that understanding, a lot of people won't practice the material before the test. So, well, one, we could put it due on Monday, but then that would cause confusion because, well, wait a minute, everything's due on Tuesday, Thursday. So does everyone kind of see the situation that, I don't know. I do understand. I saw it a long time ago, and I was like, I don't like that we have it due on the test. But I'll put the exclamation mark before it. I'll go put it like that. And so hopefully everyone understands. But can I just quick clarification on which units are on the test? So the units on the test are, let's talk about that real briefly right here. So I like to put just pivot over here. Pivot. And chapters 1 through 8. If you want to know, we can go into specifics on any one of them. But pivot in chapters 1 through 8. Does that make sense, Catherine? So generally speaking, it would be like understanding variables, categorical displays of data, quantitative displays of data, comparing distributions, normal model, correlation, regression. They changed the names of chapters 2 and 3 a few semesters ago, and that always confuses me. Chapters 2 and 3 are basically the pie charts, bar charts, histograms, kind of the understanding categorical displays and quantitative displays of data. And then this is like stacked histograms and everything right here. Like this is bivariate displays. And then we get down here to, so we get kind of like categorical displays are going to be like your pie charts. And this is going to be identifiers. Well, we don't want to put identifiers first. Those are not super important. I mean, they are. Like, someone could be like, those are the most important. Nice job, Campbell. Great job. Quantitative, categorical, and identifier. There we go. There's not even a black pen anymore. We'll go space pen. Quantitative data, that's going to look like histograms right here. Comparing distributions, that's going to look like, we could do box plots. That's a big thing in this chapter. So definitely knowing box plots. Normal model, quantitative data, correlation, regression, and regression wisdom. 2 seconds. I'm going to draw a little more on this. So what am I illustrating here that regression does what to correlation, basically? Regression pivots its own thing, so we should put... What am I illustrating right here? Can you go over the practice exam question 3 part 3? Yeah, let's do that next, Campbell. You got it. What am I illustrating right here with regression does what to correlation, basically? Regression is the what? Like, you can kind of see a summary. Oh, sure. We got it, Campbell. You bet. Regression does what to correlation? Like, correlation and regression, like regression is extension. So what does regression do to correlation? There's like a visual summary of every chapter, basically, right now. We'll put this like, what does regression do to correlation? What is the idea of linear regression? So you can see right here, here's correlation and here's regression. So where does regression go further? Correlation shows the relationship between two variables. Let's see. Pretty much, Adam, you're on the right track right there. So correlation is always between two quantitative variables, and we can look at the strength, direction, form, unusual features. Can you go over the problem that has the cyclist average speed? You bet. We'll do that one next. We'll do the question 3, part 3. Then we'll do the cyclist one. You bet. Chapter 8 quiz. Oh, yeah, we haven't done chapter 8 quiz yet. Can you give a summary of pivots? Yeah, we can do that next. We'll do that. We got like some order here. We got, that is third now. You got it. So what does everyone notice about regression? Regression does what? Regression fits a line through the data. Does that make sense? Regression is going to take this line, and so the regression fits the line through the data. And then in regression wisdom, what is the last condition right here? We see QQ, which is two quantitative variables, straight enough. There's no outliers. And then in regression wisdom, we start to talk about, especially we go into more detail on what condition. So we'll start bringing up. So exactly, plot doesn't thicken. Great review right there. QQ, straight enough, no outliers, plot doesn't thicken. I'm going to pull up I think it was the practice question first. I'm getting my Pearson loaded in the background. Let's go look at that practice question. 2 seconds here, everybody. Let's go look at the practice question. It's the practice question song. I want some music while we do it. A little chill music. We are getting the practice test up right now. Practice test is appearing. Question 3. Make sure. Question 3, part 3. I love it. Oh, yes. It's a perfect question. It's a David M. Lane question. So, no, it's suppose another student, David or something. Not a David M. Lane question. Alright, here we go. We have the question, and it's on the screen. Lower the music a little bit here. Okay. So with this right here, suppose the number of minutes a customer is put on hold at a particular phone company is approximately normal. So that's key right here. We see that it's normal. That's a big thing. So that means they've already met the normal distribution with a mean of this. So now we need to mark the mean. So let's go right here and mark that this is the mean. And a standard deviation of this. Betty called this call center and was on hold for this. So this is where people usually forget. This is going to be her Y. This is her observation. So that's her observation. This is the mean. This means it's normally distributed, which is capital N right here. So we might say with this right here, capital N, that it's normally distributed. Every time Mubot says that, he draws my attention. I see that. So I did something, like I put a thing that reminds you to tag me. And then every time I see that, I'm like, wait, what did someone just say? Because I see the orange on the screen. Calculate the z-score for Betty's hold time. So Betty's z-score is going to be observation minus mean over standard deviation equals z-score. So let's go ahead and start plugging this in right here. That's the z-score. So we observe 7.5. We subtract from it the mean of 4.9. And we have the standard deviation of 1.4. So let's go ahead and take this and find the z-score. And then what does this mean? And that might be the next question. So please tell me if I enter something incorrectly. So it's 1.86. So interpret the number you calculated. It is the next question. So what this value means right here is how many standard deviations Betty was above or below the mean. So we'll just draw this out a little bit and I'll speak over it. Nice job right there, Campbell. So we have right here, we draw this right here. I think it'll help with the next one. Do you guys like the music when we're working, or nah, I don't? It's distracting. Like, do you guys think like music good, music bad? I will be open to either viewpoint. Like, music makes it chill, or music is like, this is distracting. Leslie says, I like it. Cool. It's a sometimes thing. It's like chill. So I don't know. To me, it's chill. So we have right here the z-score. So the z-score of 1 point is going to come in use for the next problem, I believe. If this was a test, I would not be writing this out. Thank you so much, everyone liking the music here. You don't feel like it. You can be like, I hate the music, Brian. It's super distracting. Stop it. And I'd be like, I'm not going to hit the button because I want to keep going. So we have right here 1.86. This is the z-score, and I want to note that these are all z-scores. Now, in context, the numbers, which I'm going to have to do something like this. In context, this would be like 4.9, and the next one would be, we have to add 1.4. So the next one would be 6.3. What is Brian doing right here to get the context of it? What is Brian doing right here to get the context? Did I do this correctly? My brain's breaking. Yeah, I did do it correctly. 7.7. So it sounds a little bit like Minecraft, a little bit. Minecraft's very ambient. So what am I doing right here with these red numbers? I'm doing the context, and every time I'm going up by this amount. So you can see the context of it. Does that make sense? What we have here, it's like her time was 7.5. So 7.5 is right here. And so since the score is positive, it was negative. Exactly, Campbell, exactly. Since the z-score is positive 1.86, it means she's 1.86 standard deviations above the mean. And we can kind of see what's going on here with the mean and the standard deviation. This is the mean, this is the standard deviation. And so we know what's going on. That's kind of key right there. So this is where it gets a little tricky. This is a tough problem. It's a multiple choice, but it's a tough one. Another customer, David, called the same technical support, had a z-score of this. So let's go ahead and plot David with Space Pen. Space Pen is back. That's David's time right here. Space Pen. Can't do that. There we go, Space Pen. So there's David's time. What % of customers waited longer than David? So what % of customers waited longer than David? Now this should narrow down your answers. This should narrow down your answers right here. So remember, David has z-score of negative 1.55. Does anyone between a few answers? What answers are you between right now? What answers are you between? There should be some answers you're between. Ah, Campbell, I love seeing that. I love seeing that, Campbell. I like that. I like that. Campbell's like, I got it. I figured it out. Campbell figured it out from here. So what answers are you between? I think there's only two. Well, it might make the answer jump out when you see this visually right here. Seeing this visually might make the answer jump out. Do we have a formula sheet? The formula sheet you can print out or write it down. It's very small. I have it over here somewhere. Here's the formula sheet. Very small. You can write it out. So what is the answer? Let's see. Yeah, show it to the camera. Show everything to the camera. Yep. So it's gonna be. I don't think we have good evidence above 60%, and I'll explain why. Let me do some colors right here. So let's go with purple. Okay, so what do we got going on? We know it has to be what to this area? It has to be what to this area? This area right here, it has to be what to? Like this purple area, the yellow area has to be what to it? This purple area, it has to be what to it? So that's a purple area, and it must be water to this purple area. It must be what to this purple area? No one knows. No one knows. It must be what? Like we've got this area right here, this yellow area, and then we got this purple area, and the yellow area must be what to the purple area? Like you just think visually, the yellow area must be what to the purple area? It's higher, exactly. The yellow area is higher. Can anyone estimate what the purple area would be? It's above 50%, or I think I just gave the answer away. The purple area from there over is 50%. Does that make sense right there? That's 50%. So we know that the yellow area must be larger than 50%. But then let's do another area with the red pen right here. And we're going to do this. So now we've got this red area. We got this red area. And the yellow area must be what to the red area? So there's the red area. And the yellow area must be what to the red area? So we got the red area. And the yellow area must be what? To the red. Lower, exactly. So now I have to figure out what the red area is. And this is maybe where people get tricked. Because they're like, how do I figure that out? So this, we need to figure out what this is right here. And we could add that to 50%. So how much area is between there and there? Yes, that is correct. Great job right there, Campbell. Yes. You did the next step. It's 34 because this is 68 total. Oh, you can't see. I was using Space Pen. This is 68. Trust me. All right, I'll make the red go away. This is 68 total inside of here. Like inside of here and here is 68. That makes this 34. That makes this 34. And so all of our long work right here, like just to find out that this is 34. And if that's 34, then all the way across is 84. Which means the only answer that satisfies is this. Does that make sense? We just basically did like a super solve of it, and that's why I drew it out for the top one there so we could solve it, because we could have made it harder by putting like 85%. So imagine if this was, you know, if 85% was one of the answers, you might be like, ooh, I don't know, 85 could be the answer, because 97.5 just does not look visually like that. That looks to be 71%. So a good drawing can solve this problem pretty quickly. Yep, great question, Campbell. This was a tough one, and a lot of people say, well, how can I solve this without the David M. Lane applet? And so we sometimes ask questions like this right here that have it just perfectly on time. I think the next one was the cyclist question. Let's see here. I think, was it Jensen asked the cycling question? And then we're going to do chapter 8, I think someone said. Oh, wait, no, I think was there one before Jensen's? No, wait. Can you go over chapter? There we go, that. Can you, Jensen asked then, can you go over chapter 8 quiz? Can you problem cyclist average by year? Yep, let's do the cyclist average by year. So 2 seconds while we hold this up right here. Cyclist average by years. How's everyone doing today on this fine? How's the weather in Knoxville today? How is the Knoxville weather? I'm signing it. So now we need more music while I get things going. Starting early is the key. And then, so great job to everybody who, that's why I always love when people coming in here with questions, because if you start early and you find you have questions, you can ask them. And then, but when it's like 2 a.m. the night of the exam, which I spent many a nights, a lot of my advice is like, don't be like Brian advice. That's my advice usually. It's like, here's what I did. Don't do what I did. So I spent many nights, like staying up all night studying. So don't be like Brian. I mean, I don't know. Brian did it, so you be like, I'll be like Brian. Maryville's rainy. Overcast weather. Nice. Weather's blah. Thing is nice. Yeah, it's like rainy outside here. So whenever you use the curve, put the numbers 0, 1, 2, 3 under it because the z-scores. Exactly. Campbell, just to mention Campbell's last comment right there. Campbell, I always do that. I always put the context and I always put the question. Like, I wonder if I can, just to show, I ran out of space below it. So usually what I try to do, does this make, whenever you see, if you watch me in class, like draw these, here's what I do. We're going to lose that dot right there. I usually do something like this. Does that make sense, Campbell? So I always write out the numbers and the context. Like this is the context below it. So that way I can see like this is the z-score and this represents 4.9 because 4.9 was the mean. And then I go up one standard deviation. So I always put my numbers and then I put my z-scores. Z-scores remain static. So if you have a scratch sheet of paper, you could just erase these when you get to a different problem because everything you do here on the curve on your scratch sheet of paper with the z-scores can go to any problem. So your z-scores remain constant. Yeah. So I always put the z-scores below it to begin, and then I do my my context. Like I could say like a test had a mean of this. You could write the same question but with different context. You could just say like a test had a mean of 80 and a standard deviation of 10. I've been using that a lot lately. And then you could just go here and do this. And now you've put the context, and then you could erase these numbers later. You could say what percent of students made above a 70, maybe 84%. So you can always just, it's the best way to solve these problems is just to always have like your z-scores and then your context below it. And then you can see, you can say like, what is a 90? It's a z-score of 1. Okay, the cyclist one. Let's do this. Okay. I think I see that. I am so blind, everybody. It's bad. 2 eye surgeries and still blind. 100 years ago, the fastest cyclist. That's more than 100 years. 115 years ago. Oh, it's way more than 100 now. My Pearson's getting old. 118 years ago, the fastest cyclist finished a course of an average speed of 25.2. You're welcome, Campbell. 25.2 kilometers per hour. I don't know what a kilometer is. In 2005, another cyclist averaged 41.7 kilometers per hour for the fastest average winning speed in history. Complete parts A through C. So one thing you'll notice about the data right here is due to the wars, you're missing cyclists from 1915 to 1919 or 1918. There's a gap, and that might be the only gap. So let's look at the data right here. Okay, there's a gap right here in this data, and there's another gap right there in the early, I think that one's a war. So there's no gap right here, so that one's wrong. There's no gap in those, and there's no gap in that. I think it's going to be D, because in the 40s, we should have a gap also, and you see it right here. There's a big gap due to World War II. Yep, there's a gap. You got Jensen. Excellent work. Jensen, I don't know why I didn't make Jensen modder in them. So let's go ahead right here, and we've got the answer is D. Oh, this one. So we're going to have to use jump to solve it. That's not the part I'm worried about. Describe the relationship of average speed by year. Be careful to point out any unusual features in the plot. The relationship is positive, true, with a moderate scatter. Well, these all have to be true. The general trend is this. Okay, wait, no. Here we go. The general trend is linear with no races between this and this because of this. It has to be A and D. It has to be A or D. And there's some linearity to this. But this right here at the start especially is some major nonlinearity. There is saying the general trend. That's the problem. So you get to see the right answer. I'm going to go with, and someone can be like, no, Brian, don't do it. It has a linear aspect to it, but then there's some non-linearity. Let me look at the final one. I got this part. It says generally linear. That's, yeah, it's because there's a way to tell. Here we can answer it statistically. So here's how to get it. Here's how to get the answer into jump. And there is a way to tell if it is linear or not linear. We're going to copy the data to the clipboard. So make sure to copy right here. And then what does jump say? Here's the answer for what jump says. We're going to go to a new data table, file, new data table. And you would do linear. Kayla, is awesome. And this is what we're covering this week. Check it out. We're going to go right here. We're going to go to paste with column names. Then we're going to go to analyze, fit y by x. And notice that they're both quantitative because Q straight enough, no outliers. We're going to see if the year can explain the fastest time speed. And there's the trend. We're going to put the line through it. We're going to see an issue right there. And jump says, oh, really? Really? It's not giving us, I don't know why it's not giving the lack of fit test. Oh, I know why it's not giving the lack of fit test. Because it doesn't have replicates. You need replicates to do lack of fit test. Just to very, very quickly show that, I'm sure Toolon's very interested. You need replicates, which means repeated values, and we don't have any repeated x values. So without repeated x values, we cannot get a lack of fit test. All these little nuanced things, so there's no repeated x values in this instance, and so here you can see it's not going to give me the lack of fit test. So it says no duplicates, which are replicates, but the linearity, which is the lack of fit test. So if I were to add on to this more values, like if I were to rep this or something, but this hits into the same problem as the previous one, that it doesn't have duplicates or replicates. So it's saying mostly, I mean, this is linear, this is not. That's a problem right there. Generally linear. Good thing it doesn't say it's really linear, because it's not really linear. Here's the regression equation right here. This is the slope, or the intercept. My gosh, my brain is broken today. That is definitely not the slope, since it's positive. And you can see it hits way off the curve. So you'd have to go all the way back down here. Now, one thing I want to point out is that the intercept is not where you see this hit. That is just a visual spot it hits. We need to take the intercept right here from jump. And please ask if you didn't get the jump data. I can go back and review it. But we need jump to solve this pretty instantaneously, round to 2 decimals as needed. And then round the year coefficient to 3 decimals as needed. Okay. My gosh, that is... Please tell me if you get a decimal wrong, because I am one to get a decimal wrong. And there we go. Are the conditions for the regression met? QQ straight enough. No outliers. Plot doesn't thicken. Okay, no, the relationship is not straight enough. Yes, the variables are quantitative. The plot seems to be straight enough to fit a linear. There are no real outliers. Will there be one on the exam? I don't love this question. It's highly unlikely. You have to know how to read jump output. You have to know how to read jump output. You won't have to use those equation things. The formula sheet has all the formula sheets you're required to know. Yep, putting it into jump is the key to solving this one. And then knowing how to read jump output. So that's why this question's good, is the reading of jump output. Yes, relationship is not straight enough. But we said it's... Wait. Because no, the relationship is not straight. So are the conditions for regression met? So, okay, this is possible. So the variable is straight enough, the plot straight enough. There's no outliers. Yeah, Kayla, go ahead and ask it. Yep. The relationship is not straight enough. Okay, wait, so this one can't be right. So yes, the relationship is not straight enough. That's a problem. So it's between these two. The plot seems straight enough to fit a linear regression line. I mean, the thing is up here, which I think we have to go with what we said up here. You think it's A? I know it's... The problem up here, there's a general linear trend. I'm going to be really... Yeah, you're right. Nice job, Jensen. That is confusing. That's a tough one. As usual, if you selected this one, then just... I mean, I purposely got it wrong right there. Great job, Jensen. These, which Kayla's pointing out, these kind of come down to judgment calls sometimes. So it's really hard. I tell you, awesome. Thank you so much, Kayla. I think we got one more, and then Kayla's question's next. Great job, Jensen. Huge help right there. Let's throw 50 points in the chat for Jensen helping out. What we want to see, and we will try to make this very clear on the test. We will try to make the relationship, like whether it's linear or not linear, super clear. This one is tricky, and those multiple choices don't really... They do want you to see this. They do want you to see this. So I think it says this right here. In the early part of 20th century does not fit the regression line. So they do want you to observe that. So they want you to see this, which jumps out to me immediately. But that is like, that's pretty tricky. And I've done this question a lot. It's just like, okay, what do they want us to say about it again? But definitely understanding your equation right here is pretty important. Understanding all the output. Understanding all the output. Other questions, like I like the other ones in chapter 8. I love this one right here. This one's just fun. So this one right here is going to be E. We'll do this real quick, then we'll do the next one. This one's, watch me get it wrong. B is going to be slightly positive. And then this one right here is going to be C. And then this one's going to be D. And life is good. Okay. So let me see. There was one more question. We have Kayla's. So whenever, no, wait. Do we have a formula sheet? Can you give a general summary of pivots, an example of one we would have on the test? So that's a really good question right there, Addie. So when it comes to pivots, and I guess we might need to open the notes for this, knowing how to read pivot charts and what can be done for pivot charts is very important. So knowing how to read pivot charts and what can be done with pivot charts is very important. So let me go ahead and bring up the pivot chart notes. So let's go ahead to pivot chart notes. So lecture. So we're going to bring up the pivot chart notes and just mention briefly right here. We're going to go to Kayla's question next. So here are the pivot chart notes opening up on the screen. Let's take a look. Open. There we go. Enable editing. So when you look at this right here, it's a very short chapter with not a ton of information. You've got how we display the data. Head over here to lecture screen. Oh no, I've got PS320 slides up. There we go. So we've got how we display the data, and we've got just choices on how to do the value field settings, super important. You've got a pivot table, fun. You've got pivot charts right here and the elements we add to pivot charts. So super important to know what a good pivot chart looks like as a final result. And then also to know, finally at the end, how to read pivot charts and what can be done with them. I think a lot of people get confused because you might get a pivot chart like this right here. And what does this tell you? What does this bar specifically tell you? Who could summarize kind of what this bar right here tells you and what this bar right here tells you? So summarize for me a little bit about what number 1 tells you and what 2 tells you. So think about what the title says on this. Not the best descriptive title in the world, but this one made my head hurt. That one made my head hurt too, Jensen. So how would you describe point 1 Brian's talking about and point 2? So look at the graphic and be like, how would I talk to someone about this? And because you might have to interpret these to someone on a test. You might have to explain certain aspects of this. So understanding the concepts right here of this and reading through the title and reading through everything right here. Exactly, Addie, you are right. This is like how many people are in each group. So there were 248 responses from females who are single. Exactly, there's more responses. Exactly, the single females who responded. So this is the count of the individuals who responded. There's no, I think previously we asked how many children do you want to have? We're not looking at how many children people want to have right now. We're looking at just how many people in each group responded. So there were 11 males who responded that it's complicated for their relationship. Then right here, how would you describe this one right here? So let's just put that one right there. How would you describe that one right there? How would you describe that one right there? So what would you describe? Be very careful. This one's a little trickier. So how would you describe this? Look at the title of it and figure out how to describe the information given to you. Then we'll do Kayla's question next. Thank you so much. Put questions in queue, everybody. It's your time to ask questions. It's your time to say review this. Close. The second answer, Addie, is closer to the right answer. Good job right there. It's closer. So I definitely need to give the answer to this one. So we're looking at only the maximum value for each group. So in what we're saying right here is the maximum value for single females. Yeah, the title change is definitely, yep. So the maximum value for single females was that at least one person wanted 16 kids. So when you're talking to people, there was at least one single female who said, I want 16 kids. So it could have been 3 people, but the highest value for that whole data set when we talked to people was there's a single female at least who said 16 kids. And then you can see here, generally males, only in one category, males are higher than females. There was, in this instance, an engaged or married male, at least one, that wanted 12 kids. So the highest value for the engaged or married males was 12. It doesn't mean there was one, but there could be more. I mean, it'd probably be unusual if there's more than one because it's a maximum, it's an outlier, but it doesn't mean. Just right here is the average. So hopefully understanding kind of what are the options with data tables, with access titles, with chart titles, with controlling the decimals. Does everyone feel like they have a decent understanding of like what we could do with pivot charts and pivot tables? Like understanding how to make them and how to interpret them is key. Like understand how to make them and how to interpret them. And I think you might have put, let me see here. I'm finding Kayla's question. Kayla, there we go, right here. I'm going to take a, do you mind if I take screen, Kayla, do I have your permission to show this on stream, obviously? I don't believe they answered the survey honestly. they might not have. I mean, there's people who want 15 kids, and if you want 15 kids and you want to handle that, then you are mine. Yeah, exactly. The question is there an additional library we need to access survey 11? You shouldn't. Did I use survey 11? Did I use survey 11 in this? Oh, no, no, no. Oh, no. The assignment has an error. Oh, I'm a fool. It already has an error. Thank you very much. The assignment is impossible right now. Man, so Kayla, I need to re-upload the assignment. Let me fix it. I gotta tell Terry real quick. So here's the fix. See, I didn't change this for the previous ones. Okay, did you see the fixes I just did? Which screen are we on? We're probably on our screen. Okay, so thank you, Kayla. Let's throw some 50 points for Kayla right here. So that's my error. Pretty much, Addy, like interpretation, not quite like tell me what this means, but like there might be multiple choice things, but understanding how to read them is kind of the key. Understanding how to read them, and a lot of true, false, multiple choice. So I need to update this. So one moment I'm probably going to go into space and update this for both classes, and I'll email Terry and say, please send this out. Let me make sure this works now. So my sample, oh yeah, because this. My sample not found. What did I do wrong? How am I breaking my own code? It should work. I'm going crazy. So let's run the code individually. Oh, ha ha ha. There we go, there we go. I didn't see why it wouldn't work. Okay, because I hadn't loaded string R yet, so load your chunks above. So you see I run, just so everyone can see, when my code breaks, you always run your code individually to find out where the error is. And then I saw, because I know the error, it says cannot find function string R or string length, and that's because that is in the string R package. So if you encounter errors a few times, you know where to fix them. And so now let me remove this, because we don't need that in there. That runs. Let me go to space. Let's put on the music here. Ask questions. We are currently open for questions. So we're always open for questions, but we don't have one lined up. So I'll have to I'll have to figure out some questions. I need to email this to Terry. So let's call it update. There's always an update. I thought I had it working perfectly last night. 2 a.m. Brian was made an error. That's because I didn't use my sample. I just used EX5 bike when I was doing the example. Yep. Let me post it right now. I can probably post it in here. It is on, there we go. It is on Discord. And let's see. So let me get this fixed as we talk. And thank you, everybody. Also, thank you, everyone, for understanding. It's like no one's ever gotten mad at me. It's like, how dare you make a mistake, Brian? How dare you? I'd be like, I'm sorry. I just do it to show I'm human. We catch the errors. We fix the errors. That's where we start earlier. So let's edit this assignment right here. Some nice music. Could you imagine that? Someone just like being mean. And I need to send out an announcement. I know a few people downloaded it. Thank you, Kayla, so much for starting early and catching that. Could you imagine if everyone started Sunday night? And then Sunday night, everyone's like, it's broken, Brian. It would be my fault. It would be my fault. And you can start Sunday night. Someone might be really busy. So, okay, I need to send this to Terry. And where is it? I swear I just sent something to Terry last night. Let me go look for the email. Here we go. Oh my gosh. Oh wait, that's 2 p.m. Here we go. Here we go. Okay, sending this out. And we'll see if there's some questions here in a moment. And I think we need to send an announcement. Let's send an announcement with the code. Small update to assignment 5. The assignment has been fixed, has been updated. Make sure to use the current one. The following code is now. No changes. Music. We'll finish now. Changes need. The file is updated for you, so don't worry. There we go. Okay, announcement, small update to assignment 5, send. Small update to assignment 5, send. There we go. We're good to go. Brian tier, I love it. Awesome. Could you do chapter 8 homework about the animal lifespans? You bet. Yep, and Kayla, it's all, does everything make sense now? Everything should be all posted and all updated. And thank you so much, Kayla. Amazing catch right there. Let's do that chapter 5 homework, chapter 8. Oh my gosh, my brain's broke. Anyone else, like, I love it on Reddit. Someone posts like, we're this % through the semester. And I'm like, thank you so much. It's good positivity. It's good, like, positive energy to like keep your eye on the finish line. And so we're going to do chapter 8, animal lifespans. Do we have it as the quiz? Import data set. We don't want to import data set. You got to have that positivity. You got to keep your eyes on the goal. Here we go. We found it. Look at that. Look at that positivity. The world just brought it to us. So let's do this. Yeah. Let's hop over here to the main screen. Yeah, it's like a Zelda thing. It's like Zelda with the hearts. I saw that too, and I'm like, that's good. Yeah, makes me happy to see too. You always have to have that positivity. You have to be like, we're in this together. We got this. Here's the finish line. You're going to make it. You're going to do it. You got this. So for this data, R equals 0.52, 0.542. That's the correlation. Correlation is going to show us strength, direction, form, unusual features. The strength is moderate strong. We got an unusual feature over there. We've got here the form is mostly linear, a little bit of non-linearity, but mostly linear. And you see there's the non-linearity, mostly linear. The direction is positive, and the unusual feature is humans, which give us, just something that's a big outlier. For the data, the correlation is 0.542. So you should know the notation on correlation. Make sure you know that instantaneously that is sample correlation. This is not a very strong, it's moderate. Do you think the association would be stronger if humans were removed? So what we need to think about right now is if we were to remove humans, what would happen? So what is our trick to figuring out correlation with the drawing? When we're figuring out correlation, what we do is we draw around it. So let's draw around it right here, like this. And then we draw around it without the point. Now, the highlighted portion looks more like a what now? Removing humans, the highlighted portion looks more like a what than the previous one. Like, just look at the highlighted portion, and it looks more like a what? What does the highlighted portion look more like? Awesome, Kayla. Thank you so much. Thank you for finding that. What is the highlighted? Exactly. And it looks more like a 1, right? Does that make sense? Like, a student once told me that if you have points that are like a blob, they'll look like a 0. If you have points that make a 1, then they'll look like a 1. So even if they go down, they'll make a downward 1. I can't believe I didn't even realize this till they're like, if you draw around it and it looks like a 0, then it has like 0 correlation. So if you have this right here and you draw around it, it's going to look like a 0. So student, I think her name was Miranda, just like, God, 8 years ago. But told me this right here, told me this secret. of just draw around it, and whatever it looks like it's closer to. So obviously, removing the point, we can see it looks more like a 1. So when we see this right here, it would make the correlation stronger, closer to 1 from 0. So the correlation would be stronger, both the slope would increase. Yeah, the slope right here, that might be a harder one to understand. The slope before, like with this point, is going to be something like this, and then without the point, it's going to go up. The point is pulling the line down towards it. So the correlation would go up and the slope would go up. Here's the correlation without the point, and here is the correlation with the point. Yeah, without. There we go. So you can see the line going through gets pulled down and the correlation gets weaker. When you remove it, it gets stronger because it gets tighter, and also we see the slope goes up. So there we go. It's not, that's weird. Just a weird answer. Is there a reasonable justification for moving humans? Sure. Just say we're not studying humans. Restrict the study to non-human animals would justify it. Sure. Here's a scatter plot. Well, thank you for making a scatter plot for us. And they give us notation right here. With this notation on the screen, we see the constant, which is going to be B0. Now, so you have to know they're trying to tell you the notation right here. So the notation is going to be B0 plus B1, and then this is X. So this is very, 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 very similar to your jump output, where on the jump output, you can see right here, we have B0 and B1X. B0 and B1X, here's the intercept, which is the constant. And then you have the year right here, which is the X variable. So this is the X variable. I'm losing track of my little thing right here. This is the X variable year, and this is the X variable life expectancy. And then you can see the estimates, which are the coefficients, which are B0 and B1 respectively, which go up here. So hopefully that helps draw some parallels between what this output is and where we're going to use it over here. The association is, let's see right here, it's not perfect. It's not perfect. It's much stronger now, but it's not perfect. For something to be perfect, it would have to make a perfect line. All the points would have to be perfectly on the line, so it's not perfect. Interpret the slope for, on average, for each year increase in life expectancy, the gestation period is expected to increase by about this much. So we just need the coefficient of the slope, which we've identified is B1 behind me right here. This is B0, this is B1. And so let's go right here. Does it want all the decimals? Round to 2 decimals? Really? You give us 4 decimals, then you do this? You're welcome, Jensen. Anytime. A certain mammal has a life expectancy of 32 years. Estimate the expected gestation period of this species. So we're going to take this equation, and let's see, do we still have it as a screenshot? We do. So let's go ahead and take that screenshot. Let's bring it over here. Let's write our equation that y hat equals, oh, we can do it. We can say life expectancy. Life, sure. Life, predicted life is equal to 93.1, and I'm just going to abbreviate, 271. I don't want anyone to think not to carry decimals. Plus, because it's positive, so plus 12.8833, and then gestation. My G looks like a 6. Now it doesn't. And that's multiplied. So let's go ahead, and it said they have 32 years. 32 years. So 32. 32 times 12.8833. And then we add to it 93.1217. There we go. And we're going to copy that. We just plug in the value. And we go right here. Do not round to the final answer, then round to 1 decimal. There we go. And has that got it? Nice. We like that right there. Not today, my Pearson. Not today. What questions do we have? We're still going right here. We're still reviewing. What questions? Let's see. We just did this one. We did the cyclist one earlier. We haven't done this one yet. Let's go do this one next. We got right here a plot. Look at that. A little bit of heteroscedasticity at the end. Here's a plot of the interest rate on a 3-month bond from 1950 to 1980. So it's years since 1980. Did we do this one last time? No, I don't think we did. And a regression model to fit the linear regression relationship between the years and the bond percent rate. What is the correlation? So we have r squared right here. To find r from r squared, we need to square root this, and it is positive. We know it's positive because the line goes up. So we're going to take the r squared and use it as a decimal, square root it, and there we go. That is the correlation. So the correlation round to 2 decimals. There we go. Interpret the slope and the intercept. On average, interest rates during this period, there's the intercept, there's the slope. They increased by about, and this is a percent right here. This is a percent. So by about 0.2, and how many decimals? 2 decimals. 2.6, starting at an interest rate of 0.34. What does the model predict for 2020? Well, that's going to be an extrapolation. So that's an extrapolation. Yeah. Which chunk question? Well, I can't. What does it ask, Julia? And then I'll talk about it conceptually. Like, can you mention like it talks about this concept? But so mention what it talks about conceptually, and then I will kind of like briefly, I'll like explain the concepts behind it. So, because I don't want to like pull it up and like I don't want to give away the answer too much, but I'll explain. You can be like, okay, that helps. That makes sense. So, what does this model predict for 2020? So we're going to take this same equation and do what we did last time. It's asking about R squared. Oh, and what does it ask about R squared? Does it ask to find correlation from R squared? What does it ask about R squared? What does it ask? I might have to go look at it. So we have an R squared right here. R squared is the percent of variation in Y explained by the variation in X. And we do have an equation right here. So this is, I think it's bond or something. We'll put bond right here. 1%. So I'm confused on how to get it from the data. Does it give you correlation? Does it give you, I'll go take a look here in a second. The output might have R squared in it. Check to see if the jump output, because jump usually has R squared in the output. So jump usually has R squared right up here. This is where jump reports R squared in the output. So see if R squared is in the output, because jump usually reports R squared in the output. And then this is year. Yeah, sure, Calvin. Go ahead and feel free to ask. It is there, Julia. So it is it supplied to you? And I think we're talking about year 2020. Used to be so far in the future when I started doing these problems. Oh, sure, Calvin, ask away. Feel free to. So we have that this starts in 1950, so that's going to be 70 years. So the reason we're using 70 right here, there you go. And we talk about R squared as a percent, like the percent of variation. And you see they do it right here. So that can be confusing how you have to change from percent to everything. You're welcome. You're welcome, Julia. Great work. Like, I love it when people come in here and ask questions and then figure out the answer. That's the goal of this. It's to kind of like help you to realize like, oh, wait, I have to do this. So I think Kelvin, feel free to ask your question and we will do your question, Kelvin. So there we go. Here's this one. We shall solve this problem. I think we got everything right. Round to the nearest integer. Well, that's a big round. So, and I think, no, not really. Extrapolation 40 years beyond the model is not a good idea. So, and I think we've done everything. I get so afraid. And we did this one today. We did this one today. Same one right there. A variable that is not part of the model but affects the model that appears to be related to. So a variable that is not part of the model, it's hanging out on Reddit and it's not talking. So a variable, the question gives you the residuals and observed and is asking what the predicted value is. Oh, cool, let's do that. Let's make up our own problem here with a residual and the observed, and let's figure out the predicted. And we'll do that next year, Calvin. We'll finish off this quiz right here. Does anyone know a variable that is not part of the model? It's like something on Reddit that's like hanging out, but the other variables are not there. Oh, so I plugged in 70, Tori, because it wanted the year to be 2020. So the reason I plugged in 70, why did I plug in 70? If you look at this right here, does that make sense? Because it said for year 2020. And then look at this right here. And Tori, great job with lurking variable. It'd be a lurking variable. Like we think about with shark attacks and ice cream sales, the lurking variable would be summertime. So it's like summer is actually the reason there's more shark attacks. Summer is the reason that there's more ice cream sales. But the lurking variable right there is because you can say shark attacks and ice cream sales are connected, but they're not really connected. It's just due to summertime, more shark attacks, more ice cream sales in summertime. Does this make sense right here, Tori? Why with the year 2020, I'm plugging in 70 to the model? Does that make sense, Tori? Why with the year 2020, I'm plugging in 70? So I plug in 70 because of... remember, we're using year 2020. So we're predicting for the year 2020. Oh, Tori, that's why we do office hours. Tori, I'm so glad to hear that. Tori, let's just throw some 50 points for all the positivity. Tori, that's why we, I'm so glad you're starting on this early. And then, like you could work this problem like 50 times. I make some errors. Don't worry. Like someone probably like Brian can't even solve the problems. So then we're going to do Calvin's question here. We're going to finish this off. We know that this is a lurking variable. Well, this one right here is a lurking variable. The next one, I believe, is going to be an extrapolation. Let's see if it is. Extrapolation right here, using a model to predict a y value far outside the x bounds is extrapolation. We just covered this a half second ago. That is extrapolation when you're outside the x bounds of the model. And last but not least, to look for outliers and check the equal variance assumption, we should make a residual plot. So we should make a residual plot, and we have done it. We have covered the questions. Can you read task 3 condition? Yeah, it's awesome. Great question right there. We're going to do Calvin's question, then we're going to do Jocelyn's. You got it, Jocelyn. So stay tuned. Calvin, your question is, which is actually related to 320. So 320, listen up. We got some regression right here. It says gives you the residual. So when we have a residual, that would be notation E. So we have E for residual. So let's say something has a residual of 10. And so it gives you the residual and the observed. Says the observed is Y. And let's say the observed is 15. So right now what we'd have is something like this right here. And the residual is 10. And the observed is 15. So that means, oh, well then we should have it. So let me graph it visually like this. If this right here, this is E, and I should have done different colors. I think I said, what did I say it was a second ago? I said it was 10, right? Good. And so the Y is 15, which means this would be at 15 right here. So I just want you to think about this visually right here. So we're drawing it out. We're making a graphic. So we now have the residual. And the residual so the Y value is actually 15. And gotta make it straight enough. So now we need to figure out the Y hat. So, oh, Grace, I'm so glad. So Y hat is the prediction. That's my goal with this right here. And I like using the different colors because I think it can help. So I want everyone to figure out what is, and then we'll write down the formula right here to help figure this out. So, and then we'll always remember that residual equals the actual minus the predicted. This is the predicted right here. So the residual equals the actual minus the predicted, the difference between the two. Can anyone figure out what the predicted would be from this? Wrap. Residual equals actual minus predicted. What is the predicted from this? So what would be the predicted value right here? Can you figure out the predicted value right here? And then we'll just solve it like actually. So we can see the actual point is 15. That's the actual observed value. The residual is 10. So just look at it graphically and think about what would the residual, what would be the predicted? What would be the predicted? And what does the residual mean? So what would be the predicted right here? What is the... Any ideas on the predicted value? What is the predicted value from the line? What would be the predicted value from the line? What would the line predict? So the line is going to make a prediction right here. And so what is going to be the prediction from the line? And how did you get that? And then I just want you to, you can have like these epiphany moments when you look at this, you're like, oh, that's what it means. Nolan, excellent work, Nolan. I appreciate that right there. That is awesome. You are correct. It's 5. And just think about what a residual means. It means that the point, exactly, Jocelyn. Yep, Jocelyn. We'll be doing this in 320 also. We'll be talking about residuals. I'm going to put more on residuals on the next assignment when we check for conditions. But residuals is wrap, residual equals actual minus predicted. So when you look at the residual, it's basically how far away the point is from the line. So anything with a positive residual must be where? anything with a positive residual, the actual must be what? Anything with a positive residual must be where? Really? Color change pen? Anything with a positive residual is above the line. Anything with a negative residual is below the line. And anything that has a residual of 0 is going to be on the line. So when you think about this, what if I were to give you a different question right here? And so the answer was the actual is 5. We see that. What if I were to say to you, the residual for something is -5, and we predicted it would be 20. So think about this. A residual for something is -5. Let's just write this out as a question. And I just want you to think about it like with words right now. And I want you to think about what a residual means. A residual is -5. We predicted it would be 20. So what is the actual? So if you're getting this right now, you should be able to get this pretty instantaneously. It might not work on my drawing, but just think about what the residual is, and we predicted it would be 20. What is the actual? So the residual is -5. We predicted it would be 20. What is the actual? And think, since it has a negative residual. If it has a negative residual, exactly, Nolan, yep, Addy, you're right. Because when things have negative residuals, they'd have to be below their predicted. They'd have to be below the predicted. So the actual would be below. Is that making sense to everybody right here? So we could do another one right here. How about this? Something is actually 20 and is predicted to be 10. What is residual? So something is 20 and is actually 20 and predicted to be 10. What is its residual? So pretty quick on this one. See if you can get this, and you can use the cheat sheet over here. So I'll vanish. So we can use the cheat sheet. People are getting it. It's 10. So all we're doing is 20 minus 10 is equal to 10. So the residual is 10. It would be 10 above, just like this one right here. So it's very similar to this question. Great job. Is this making more sense, Kelvin? Kelvin's question, I think, said it gave him the residual and the actual. So we could say something is actually 25 and has residual -15, -5, sorry. So something is actually 25 and has residual -5. What was predicted? What was predicted? So see if you can get this one. And then plug the things into your formula here to see if it solves correctly. So see if you can get this one right here. And then I'll show the formula down here that solves. Remember, residual equals actual minus predicted. So you can double check your work. Make sure. Yeah, that's correct. I got it. So, oops, I don't have the chat scroll down. I hope everyone's getting it. 30, yes. Yep, it is 30. So when you solve this, if you're doing the work right here, you know the residual. So the residual is -5 equals, and we know the actual. So the actual is going to be equal to 25. And then we want to know the predicted. So I have orange pen selected, minus predicted. So it's solved for P, but hopefully, no, Tori, this is the practice. Always do this right here. Do you see how what you would do? You could solve this out mathematically, or you bring this over to the other side by subtraction and you get -30. Like if you bring this over here, you'd have to subtract it. And then this would become -30 equals -P, which means 30 equals predicted. Does that make sense right here as you go through and kind of solve it? And then also remember what a negative residual means. A negative residual means that the what? A negative residual would mean that the actual is where? A negative residual would mean that the actual is where? A negative residual would mean that the actual is what? So because the residual here is negative, the actual must be what? And that's a good way to review, because this one can be quick solved like this if you know it. Exactly. The actual has to be below. Like this could have a residual of -5 if it's 5 below. So then you would say, well, then the predicted has to be above, because the negative residual means the actual is 5 below. So hopefully this helped out a lot right here, kind of just reviewing residuals and what they mean. Good review for 320 also, because we will cover this topic. And Jocelyn was wondering about, thank you, Jocelyn, for your question. Can you go over task 3, confidence intervals on assignment 5? Yeah, let's do it. So confidence intervals, which is something we'll do in 201 also, and great job, Jocelyn. So task 3, is it? Yeah, everything right here, right? So we need to create a regression right here. I'm going to create a very simple regression, Jocelyn. This is not the one from your assignment. Remember, a lot of times when Brian does work right here, he doesn't do like the exact thing you're doing. So I'm loading up a reg class right here, which I didn't know if I had it running. I'm loading up a data set, which you're not going to use. So please listen in if you're watching this. You're not using this data set. Like, you are not using this data set. So please follow the instructions. I try to be as clear and concise as possible. It is now your choice to choose a variable to explain demand from another quantitative variable in this data set. So you are not using this data set. You are using the my sample you created. You'll use that at all times. So with this right here, we're going to make a regression, probably the easiest one to make. I make it all the time right here. We're going to go here to height tilde weight, comma, data equals survey 10. So now we have a regression made. So with this right here, Jocelyn, I want you to take a moment and think what LM stands for. When you see LM right here, the function LM or 201, let's go give some 50 points out. Does anyone know what LM stands for when we run this function? And here's a hint. This is the Y variable we're using. This is the X, and this is the name of the data frame. Does anyone have an idea of what LM stands for 50 points? Does anyone know what LM stands for? Who knows what LM stands for? Jocelyn, that's exactly right. Linear model, linear regression model. You're exactly right, Jocelyn. It stands for we're making a linear model. And there is a such thing as a GLM, which is a generalized linear model. We won't use that right now, but GLM stands for generalized linear model. LM stands for linear model. If you're ever confused on any of these, you can always do the question mark. And you see it says fitting linear models right there. So this is the LM function right here to fit a linear model. So always remember we have the question mark and we won't use GLM right now, but that's a generalized linear model. You can see behind me right there, fitting the generalized linear model. So all we're doing is fitting a line to the data. And so for the other questions too, we now have this object M we can manipulate. So we have this object here called M, and it's just something stored in the brain up there of R. And what we're going to do now is we're just going to do a summary of it. And what do we get right here with the summary? I think we have to do this for this task. We have to do a summary, and we have to do, I don't think we do an ANOVA, but we also need to visualize it. This is one of the coolest things. Dr. Petrie wrote this function, visualize model, and you just go right here, and boom. Oh, because I did. I know why. There, it's fixed. Don't use GLM. Pretend I didn't show you GLM right now. It won't work with GLM on that one. So I still have my GLM stored. And so you can see right here, the model, which is now an LM, which will work for this right now, is going to create this. If you do get wacky things, please, let me point something out. You can get really wacky output. I want to point this out. If you see stuff like this right here, do not turn this in. Jocelyn, does this look good or bad? Does this look like you will get a good grade for this output? I wouldn't use this. So associate does work, but what is associate going to miss? Here, we'll go back in time. What is associate not going to do for us that LM will do for us? Like here's associate, which is a great function. What is associate not going to do for us that visualize model is going to do for us? So here's the associate output. Here's the visualize model output. And this goes into 201 because this is correlation, and then this is regression, and literally brings us full circle back to where we started here, talking about correlation versus regression. And what do we see as we go from correlation to, there's correlation, and then here's regression. And what do we see when we go from correlation to regression? Correlation, regression, what do we see? What is the big key difference going from correlation to regression? That's it right here. It's that line right there. That line is going to be, and then when we get into, we got this also right here. This is going to be the normal line. Exactly. It's going to be the line we are fitting through the data. And then you see right here, it's just like enhance. We've got right here, the plot doesn't thicken, which is heteroscedasticity we're going to talk about. So we do not want there to be heteroscedasticity. It's going to be an important thing. We've got the line, basically making it bigger so people can see this is a line in the data, and then this is the heteroscedastic we talk about with like regression wisdom. So make sure to understand that from going from correlation to regression, we are fitting the line. Hopefully. And then Interpret the standard error. So the standard error, this is a pretty interesting one where people usually get pretty confused. We do not need associate output. Do not include associate output. Here is the standard error. Now, the way the standard error works is the following, and I think a lot of people don't even realize, especially statisticians, don't realize how to talk about standard error. If I tell you, let's say we talk about how much pizza we're going to need for a party, and I say, I think we need 10 pizzas, but I could be off by about 2 pizzas. So you'd say we probably need between how many and how many pizzas. So if I said, I think we need 10 pizzas, but I could be off by about 2 pizzas. So I'd say, I think we need 10, but I could be off by about 2 pizzas. I don't know, about 10, maybe, I don't know. It could be off by about 2. Could be off by about 2 pizzas. How many pizzas do you think we would need? Then what does that mean, standard error is? So I say, let's order 10 pizzas, but I could be off by about 2. Ten pizzas, but I could be off by about 2. So what interval would you make with that? What interval would you make with, I think we should have 10 pizzas, but I could be off by about 2. Like 10 would be exactly, Jocelyn, right there, 8 to 12. And so the could be off by about 2 is your what in your estimate. So when I say, here's my estimate of 10 pizzas, and then I could be off by about 2, think of a U word, like you're very what in your estimate, or you have some amount of this in your estimate. So I say we should get 10 pizzas, but I could be off by about 2. So the 2, here's the estimate. The 2, which is the standard error in this example, is your what in the estimate. Think of a U word, like you're not too sure of it. You're something. You could say you could put the before that. So the 2 pizzas is your what in your estimate. The 2, your uncertainty, exactly. So standard error is a measure of uncertainty. Now watch this mathematically right here. You can take your estimate and divide by your standard error, and we should know this, to get the t ratio. This t ratio right here, which leads to a p-value, so all this output like goes from left to right here, where here's your estimate of what the slope is, here's your uncertainty in the slope, and then here is the ratio of your estimate to your uncertainty. We just showed that mathematically. And then the p-value is calculated by how far away your t-value, which is basically a z, is away from 0. A t of 20 is an extreme t-score. On the Canvas content quiz, is observed another word for actual? Exactly. Yep. Addie, great point right there. Observed is another word for actual. That is the observed is also the actual. Great question right there, Addie. And so with this right here, I want you to think about this. Could someone come along, Jocelyn, and say, well, Brian said he could be off by about 2 pizzas, but I want to make a wider interval. So what if that person, instead of saying, like Brian said he could be off by about 2, but let's go 6 to 14 pizzas. So they'd be using how many uncertainties? They'd be using how many uncertainties? So if we went 6 to 14 pizzas, we'd actually be taking Brian's estimate, E, and we're going plus or minus 2 of Brian's uncertainties. And what we've just written out here is a 95% confidence interval because 68, 95, 99.7. Interesting how all of this converges to 201. That first interval we made, Maddie, that was just plus or minus 1 uncertainty was a what percent confidence interval? That first interval we made for 201, you should know this for the test. The first interval we made that was just 1 uncertainty plus or minus would probably be right about what percent of the time? So the first interval that was only plus or minus 1 uncertainty was a what percent confidence interval? These are numbers we should definitely know. Good to see you here, Hannah and Grace. First interval was a 68% confidence interval. So we went plus or minus 2 uncertainties. So watch this. Are you ready? If I go right here and I calculate a 95% confidence interval, I can do it by hand. I can take this and add to it 2. I didn't do it. Nice job right there, Ben. Excellent work. I'm taking the estimate and I'm adding to it 2 uncertainties. And I'm taking the estimate and I'm subtracting from it 2 uncertainties. And then I go to confident, which is confidence intervals for the regression model. And what do we see? Almost exactly the same answer. I'll explain in greater detail in class why the t is a little bit different from the z. But if you notice right here, we get basically the same answers right here, and it would work the same for the intercept if we change the values. So with that, everybody, we will come back. We'll have class today. Make sure to swing by 201. Make sure to email me those questions. It is time to end. We'll put on a little 80s music here. Great job, everybody. I will talk to you later. See you for now. Bye for now, everyone. Bye.